This is a video about statistics, and for the duration of this video, I'm going to be calling statistics stats because I will continue to mess up, and I've had to remake this video multiple times because I keep stumbling over the word statistics, because if you say it 5 times fast, it's probably impossible. So anyway, stats is the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions. Essentially, stats is a branch of mathematics that involves collection, description, analysis, and inference of conclusions. Stats is used in a variety of various sectors, such as psychology, geology, sociology, weather forecasting. It's even used in sports. Actually, it's really used in sports quite often. For example, for football, each player, either per game or per season, is run on different sets of statistics for that individual player. So think rushing yards, passing yards, touchdowns per game, interceptions, tackles, and each of these areas of statistical analysis for each player can either be conducted per game or per season. But these stats are crucial in determining the value of the player, because obviously the higher the stat per category of data, the more valuable that the player is, and the more playing time that the player will have, or the less playing time the player will have. I mean, stats is essential in sports forecasting. So you might ask, how do we get the different data sets, or how do we conclude that formula? Well, you have to look at the data and you have to analyze the data. And all data is between 4 different areas or categories. And this is nominal, ordinal, interval, and ratio data. Let's look at nominal data. So nominal data is data that can be labeled or classified into mutually exclusive categories within a variable. And so think not ordered, categories not ordered in a meaningful way. Okay, not in a meaningful way. So think male, female, hair care, hair color, names of people, so categories. And so I don't know if this is in focus, but I have a whole little flow chart of the different types of data and how to find each test. For nominal data, think categories not ordered in a meaningful way. Okay, so for nominal data, it's going to be in between 1 variable or 2 variables. So we're going to think for 1 variable. So for 1 variable, if it's 2 categories, you're going to be using a z-test for proportions. And if it's more than 2 categories, you're going to be using a chi-square test. Now, if you have 2 variables with nominal data and it's a 2 by 2, you're going to use a z-test for difference of proportions. Now, if it's more than a 2 by 2, you're going to use a chi-squared independent test only. Ordinal data is a categorical data type where variables have natural ordered categories and the distance between is not known. So think natural ordered categories, think high, low, and middle income. That is a natural order of categories. Think rankings, education level, things that make sense and are ordered in order. So if it's independent data, you're going to use a Mann-Whitney test. If it's related, you're going to use a sign test. And that's ordinal data. For interval and ratio data, they're variables grouped into ranked categories using continuous numeral values. So think temperature, year, IQ test, SAT test. There's countless types of variables, and a lot of data falls in between interval and ratio data, which is great, but also there's a lot of tests that also coincide with interval and ratio data. So interval and ratio data can be between 1, 2, and 3 or more variables. So if your interval and ratio data has 1 variable and the standard deviation is known, you're going to use a 1 sample z-test for the mean. And if your standard deviation is not known, you're going to use a 1 sample t-test for the mean. Now, if your interval ratio has 2 variables and 2 categories, and it's related, you're going to use a related t-test. And if it's not related within the 2 categories, you're going to use a Wilcoxon test. Within 2 categories, if it's independent and then you look at the null and it's equal to, then you're going to use a pooled test. And if it's not equal, you're going to use an unpooled test. So if it's not independent, you're going to use a Mann-Whitney test. So for 2 variables, if it's 3 or more categories, you're going to use an ANOVA test. And for 3 or more variables, you're also going to use an ANOVA test. Now, I don't know if I explained this very well. I will say it is a little nerve-wracking sitting in front of a camera, but that is how I determine the different types of data sets and how you categorize them and how you use the different types of formulas to conclude the data. And that is the most important part of statistics, is knowing what formula you're using for what data you're being presented with. We would not be able to successfully determine any sort of probability if you do not use the proper test that coincides with whatever data set that you're analyzing. Knowing what formula to use is essential in calculating anything in mathematics, especially statistics. And the thing about statistics is it can get really confusing because there are lots and lots and lots of different tests and different types of variables, and you have to look at it between numeral, ordinal, or interval and ratio data. But it's kind of fun if you think about it, because it's kind of like a puzzle piece that you have to, put together at the end of when you analyze it, not at the end of the day, when you analyze the data. But yeah, so that's why I decided to choose this topic, is because, you can't do any sort of math without knowing what test you're doing. And each test is unique and each test is different, but that's statistics. You never know. There's a lot of probability. It's a lot of theory. It's very confusing, but it also can be fun, Not when you're stressed out and crying about it, but it can be fun. It could be fun. It could be fun. Anyway, so that's statistics.